Awesome, awesome, awesome. Well, I want to thank you all for joining today. Today's webinar is the 5 NetFlow myths debunked, unleashing the security intelligence of your network. And let's just go over what we're going to talk about today. So, yeah, of course, we're going to do the introduction, who we are, what we are, and why we're here. We're going to talk about what NetFlow data is, and we're going to talk about 5 NetFlow myths that we find common, and we're going to debunk them. And then we'll also give a little recap and some Q&A at the end. All right, first let me tell you a little bit about myself. My name is Jimmy D. James Doherty. I've been in the industry, or the metadata industry, for well over 20 years. I've been with Plixer for over 18 years. So I've just had some experience with this technology, and I've seen it grow from it just being IP accounting all the way up to what it is now, what you're going to learn today. And then I'd also like to introduce my good friend and coworker, Carter. Carter, can you tell me a little bit about yourself?
Yeah, thanks, Jim. So I'm the director of marketing here at Plixer. I've been here just under 2 years. And my goal is really, as the marketing director, is to keep customers and prospects, like the people in the call here, as informed about what our NDR solution is, why it's valuable to their security operations, how we can enhance their ability to detect, respond, and investigate threats. So I see it as an educational role, but obviously there's, the sales part of it too. But I really want to make sure that we're delivering high value content to our audience so that they know how best to use our solution or how best to enhance their career and their jobs.
Excellent. Thank you very much, Carter.
You
All
got
right.
it.
Let's jump on that next screen here, and let's talk a little about what is NetFlow data. And first off, we're going to use the word or the label NetFlow, right? But the concept is NetFlow was originally developed by Cisco a long time ago. It was a general protocol used for IP accounting, but the industry has come to learn that it's much more. And from now on in the conversation, when we mention NetFlow, it's really all of the metadata: NetFlow, IPFix, SFlow for sample flow, JFlow, CFlow, all of them out there are give you the ability to have greater visibility into your network without the load of probes and packet capture and all that jazz. So what is NetFlow network flow data? And it refers to the data extracted from the network devices, switches, routers, firewalls, wireless access points, load balancers, etc. And exactly in today's world, many of these devices support this flow data. And all you have to do is turn it on. It's used to tally, log, and analyze all network traffic as it passes through those devices. And think about a city, right? And there's a corner in the city that you need to get visibility on. All you have to do is go to that router, that switch, that firewall, that wireless access point that services that corner, that part of your network, and you turn on the flow, and bang, that light comes on, and you're able to see the traffic that goes to or from that corner. And it allows you to create a dynamic model of network behavior. And that's where we really want to talk to you about today. Because, like I said in the beginning, it was used for IP accounting, but as it grew, and as there's more elements, there's more information, it gives you the ability to create a model of your network's behavior, not only telling you performance metrics and other bits of information, but now in our world, it provides a whole security layer that we just didn't have before. So as it says, for simplicity, we use NetFlow from now on. That's what we're going to use as that term. But remember, it refers to all versions across the board.
Yeah. Thanks, Jim. With that said, though, we do often get misconceptions around how useful NetFlow can be. And so that's what we want to talk to you about today is what are the myths that persist and what are the what's the truth behind those myths? So we're going to do an exchange of what's the myth and then what's the reality.
So let me take this first myth, and I'm going to hand it over to you. NetFlow is not useful for security intelligence. That's something we heard from the beginning. Carter, tell me why this isn't true.
Yeah, it's a super common myth. It's definitely the most common thing we hear when we talk about creating our NDR solution with NetFlow data is people say, oh, well, that's not really useful for security, right? NetFlow only offers you a handful of data points, source IP, destination IP, source point, a couple protocols, maybe a couple more data points, but not really a large amount of data. People say, well, whatever data it does offer, even if it is more than just that handful of data points, well, it's still only reserved for layers 3 and 4. And that was true when NetFlow was originally designed in 2009. But today's NetFlow V10, IPFix, both of those are very rich with contextual data to help security analysts detect, investigate, and respond to security incidents. So may have been true of NetFlow over a decade ago. It's not true today.
You're making me feel old.
Sorry. In fact, like when properly analyzed, NetFlow can help you detect threats that have bypassed other controls. So it ends up being a safeguard against other controls like EDRs or firewalls that you might have. And that's because network flow data is generated from your existing infrastructure. It's a complete picture of your entire IT environment. We extract NetFlow data from switches, routers, firewalls, etc. As a way to build an entire visualization of your network traffic. So while it can detect threats, at the edge, it can also detect them in the core. NetFlow data also allows you to see north, south, and east-west traffic, making it much easier to detect threat actor movement across your entire enterprise. So rather just high ingress or egress points or strategically sensitive data zones, you can see the entire picture of your network and track suspicious behavior across the entire environment. And then additionally, NetFlow data is very light, so it can be stored for months with high fidelity, which allows you to more easily root cause issues, more precisely determine root cause of a breach or a compromise, so you can prevent that from happening in the future. So there's just a few ways that NetFlow can be used for security intelligence.
All right. Myth number 2. NetFlow cannot be used to detect sophisticated attacks. This is a good one. Tell us why this is a myth.
Yeah, so in the first myth, obviously we covered, that it can be useful for security, but the next follow-up question is, okay, well, it's useful for security, but like how useful? Can it actually detect sophisticated attacks? And so, despite learning that NetFlow can be helpful, people still are hesitant to go full bore and say, yeah, NetFlow is good for security. So how does NetFlow help you detect and respond to sophisticated threats? It does this in the way that we described before, by providing you a large view into your network traffic and then processing that data through a sophisticated ML engine, which then gives you a strong baseline and a dynamic baseline of the activity that's happening on your network. It can see things like network scans, lateral movement, command and control communication, privilege escalation. Just as an example, it can really detect some sophisticated attacks that often are stealthy and can easily bypass your other security controls. And people often question the depth of data that you're able to get. So on the right hand part of the screen here, you're going to see some data points. This is a sample of the hundreds and hundreds of data points that we're able to pull through IPFix and NetFlow. But it just gives you a sense of sort of what you might look for, indicators of an attack or suspicious behavior happening by the layer in which they might happen. So NetFlow and IPFix, with both of those, you can really see a large amount of telemetry data, not just about your network, but about devices, applications, etc. Flow can show you, as you see here, key data that investigates where a threat started, what's happening with that threat, how it's moving across the enterprise. And you can do that without the need to fully inspect a packet payload. So for example, you can detect command and control by using data points like URLs, DGAs, and DNS information. But most importantly, this rich data gets contextualized by sophisticated ML, as I mentioned, that allows you to detect anomalies across the entire environment. And those anomalies are not based on known or or known states or known threats or known signatures and malware. It really is agnostic. So if there's any sort of suspicious behavior happening, you're going to get an alarm based on that because you have this wide dynamic baseline of normal that's specific to your network. Now, when you look across the MITRE ATT&CK framework, Plixer's flow, ingestion, and enrichment allows you to detect, investigate, and respond to threats that occur in an array of tactic areas, all the way from reconnaissance to impact. So it really gives you a wide spectrum to protect your environment. In the security world, as you know, time is everything. You want more time to respond to potential threats. You want to know about a threat sooner so you can stop it from damaging your company. With a wide lens of your IT environment, NetFlow provides threat detections at multiple stages of the MITRE ATT&CK framework, giving you wide visibility and more time to eliminate a threat before it has a chance to cause damage. As you can see, there are multiple security controls that are more point specific. NetFlow gives you a much broader view, so you can, one, validate the security controls you have in place, but also ensure that you're seeing a threat as it moves and you have the ability to know, is this a threat that I need to respond to today? Do I have a few days? What's the urgency here? How severe is it going to be? How much activity is actually happening with this threat? So that's hugely crucial information, all derived from enriched NetFlow.
Excellent. All right, myth number 3: NetFlow can only come from select devices. And I'll be honest with you, this is when I've heard from and had to face from the early days. But Carter, tell us why this one isn't correct.
Yeah, I mean, as you mentioned, in the early days, this was more true. As you mentioned, Cisco developed NetFlow. NetFlow is a Cisco product, for a better lack of a better term. So in the beginning, back in 2009, Cisco was the only device vendor that was exporting and enabling NetFlow, but that pretty quickly changed. Many competitors to Cisco started creating their own flow protocols that were enabled on their devices. And then really IPFix has greatly opened up the possibilities. So that was a vendor agnostic protocol that really expanded any device's capability to export flow. And in fact, it allowed you to change many different types of data into flow data. So it really opened the possibilities. And with that multi-vendor change also came the ability to add flow data from other devices, enable other devices to get flow data. So for example, we get switches, routers, firewalls, clouds, and end user devices like IoT, laptops, desktops, and more. It really is a much broader and inclusive data set now than it was, like I mentioned, over a decade ago. And yeah, so obviously, like Cisco provides flow enablement, we know that, but so does Juniper, Gigamon, Palo Alto, CERT, SonicWall, NTOP. The list goes on. Really, this is just a small sampling to give you an indication of some of the bigger players that allow you to enable flow analysis. And like I said, with IPFix, the extraction of key data points has only gotten easier, which then expands your ability to get critical data about your environment so you can detect threats faster. You have deeper investigative data to pull from, and you can respond with more confidence. Okay.
Myth number 4. This is another old school one, right? NetFlow consumes too much bandwidth. I don't want it on my network. It's another thing that I got to worry about. Tell us why this isn't true, Carter.
Yeah, it is a common misconception that NetFlow consumes bandwidth and causes performance issues or it slows the network. And that it's really never been a true statement, although there was noticeable CPU impact back when Cisco first launched their flow enablement devices. So there is like a slight truth to the fact that it used to impact consumption, but even then it was over exaggerated by competitors. Direct competitors to Cisco were looking to find a way to enhance their ability to export their flow protocol. And so they pointed to the fact that Cisco's version consumed bandwidth in a noticeable way, and they were working to make their product consume less CPU, and that was a differentiator for them. But in reality, it wasn't really that big of a deal when it first began, at least not in most situations, and that's definitely not the case today. So over the years, Cisco and other vendors have worked to reduce CPU consumption that exporting NetFlow might have. So today, the impact of collecting flow is so low, it's basically negligible. So for example, at Plixer, once NetFlow or IPFix is enabled, the network overhead is usually between 0.1 and 0.3% of monitored traffic. So really not enough to cause any concern, any performance issues or hamper anything. So the myth that it's going to cause traffic consumption issues is just not true.
All right, here's the last one. Myth number 5. This is a big one. We talk about it every day. Full packet capture is better than NetFlow. Why do I want to just rely on that metadata?
Yeah, this one's huge. I mean, I can hear almost everyone in the audience saying like, okay, yeah, NetFlow can provide security data. They can help detect threats. It's widely available. It's low touch, yada, yada, yada. All that's cool. It's still not as good as the packet. And you know what? That's true. It's not as deep as a packet will be. There's no level of depth that you can replicate without the full packet. But I have some questions that I just want to pose to people about when we say, is it better? So when we're talking about packets, how many packets do you actually want to capture? Really, like how many? Is it all of them? Do you have taps, spans, probes, and packet storage in your IT environment already? Because if you don't, you're going to need those to do full packet capture. And the question is, well, how much money do you have to invest in that? How many resources do you have to dedicate to that effort? Because it can be a very complicated process, especially in a hybrid environment, to build a parallel network. Another question would be, how long do you want to store those packets for? Like how much time do you need to actually pull from those packets? Because that's going to cost disk space, extra storage. So we want to think about that. The other thing to think about is how much of your internal traffic is encrypted today. If your traffic is encrypted, that complicates the value of the payload. You'll need to store decryption keys. And again, like becomes a question of how long do you want to keep those packets? And then if you were to experience attack, what's the likelihood that the packets of that attack are going to be encrypted in a way that you can't decrypt them? So what value does a encrypted traffic packet that you cannot decrypt have for you? All of those really complicate your ability to get value from a packet payload, though there may be a lot of great data in that payload. The question to ask is how often are you actually going to be able to access that data? How important are those details for you to capture them for all the traffic happening across your network? Unless you have unlimited budget, the answers to those questions that I just posed really do call in the question of the value of full packet capture solutions. We're going to examine some of those shortcomings in a moment, so we can sort of dive into each individual issue, see how a NetFlow solution would compare to that. But I just want to reiterate that NetFlow data gives you wide visibility. It's a low impact solution. It provides you real-time detections, north, south, east, west. And you get long-term forensics, and it's not as affected by encryption because we're not looking at the packet payload. We're looking at different data points. So you can get a level of fidelity without having to inspect the packet. So like I said, in the NDR world, most vendors require full packet capture in order to function. So it's not a like, oh, it's a good thing to have because it allows you to do XYZ. No, these vendors require full packet capture in order to run their ML, in order to really run their detections. They might say that they use flow or they may ingest flow at strategic points, but they're really using either deep packet inspection or packet processing to gather the data that runs their ML and their detections. And this adds a bunch of complexity that can be avoided if you choose a flow-based solution. And I want to be clear, in terms of the NDR story, Plixer's journey is going to be different, but the destination is the same. The goal here is to protect your IT environment by harnessing the network. We just go about it in a different way than the packet capture guys do. But the destination is the same. Protect your environment, real detections, early detections, great investigative data points, and confident responses. So let's focus on sort of the complications that you might encounter with a packet-based NDR, and then how a packet-based NDR sort of would try to solve that, and why that solution might not be the greatest option available to you. So in terms of cost, packet infrastructure is just very costly. You're going to need to build parallel networks. You're going to need to deploy resources to that, both from a budgetary standpoint and also from a person standpoint. You need someone to actually architect it and build it. So often the compromise that happens is we'll say, okay, well, we're only going to place packet capture at certain areas like our crown jewels or the edge, high volume points or strategically important points to us. And the reality of that is that it limits your visibility. It creates blind spots where threat actors can hide and cause damage that you didn't foresee. So you're making judgment calls, right, about where you're placing the packets, where you're processing that data. And you might be right; those might be the places where threat actors want to go or where they're best seen. But it's a guess. It might be a strategic guess, but it's still a guess. And you might overestimate the value of certain things or underestimate the value of other things, and that leaves you at risk. It just does. It leaves you at risk. So that's something to keep in mind with a packet-based solution. Is it helps reduce your risk to a degree, but only to a degree. A flow-based solution is going to give you a much wider lens, so a much better lowering of your risk. Packets also come with a lot of complexity. You need someone to architect it for you. And depending on the complexity of your network architecture already, this might be a really difficult task. Or you might not have the personnel to do that. And packet solutions are really going to require you to have personnel do this. This is not part of their technology or part of their solution. It's on you to build it to make their solution run, their technology run. And it's a very disruptive process in doing so, which then leads to longer deployment times, longer time to value, diverts your team members away from mission critical activities, to service tools that are intended to help you, but may take some time to actually help you, and often cause extra complications in order to keep them operating at high fidelity. That's not all in terms of the complications that packets bring to you either. As I mentioned, storage is a huge one. So packet files are very large, especially if you're collecting, hundreds of thousands of millions or billions of packets every day, depending on the size of your organization. And the solution that packet-based NDRs will do is they'll say, okay, great, we're only going to store payloads for a few days, maybe a few weeks. And the goal here is to keep the cost down, because the more packets you store, the larger your storage costs are going to be. And so there's a compromise that you're making. And the unfortunate reality is that, an attack typically has a dwell time of over 280 days, according to the IBM Ponemon report that comes out every year. So it's a huge discrepancy between what you've actually stored in terms of packet payloads and the time in which you might discover an attack and then need to root cause that attack. So chances are you're not going to have access to the payloads. You're still processing the data in the packet-based NDR. So I'm not saying that the packet-based NDR won't see the attack or give you some indication of what happened, but you're not going to have the payload. And that's the argument that most people have is like, I want the payload because I want to see what happened. But in reality, you're probably not going to have that payload anymore, despite having the infrastructure in place to do so. You didn't have the storage in place to do so. And it really comes down to cost. You probably don't have the cost to actually store that level, that a massive amount of packets in your environment to actually then go root cause something that happened, almost a year ago. And then the final piece I want to mention here is encryption. So we know that something like 60 to 70% of internal traffic is encrypted, and you likely have the ability to decrypt your internal traffic, and that's fine if you're sort of trying to track down a insider threat attack. But the reality is that most of your attacks are going to come from the outside, and most cyber criminals are going to encrypt their traffic, and you're not going to have the ability to decrypt those. Even if you had the storage capabilities to store all your decryption keys and you had the payload storage in lock, you're not probably going to be able to decrypt encrypted traffic from a threat actor. And so packet solutions will say, that's fine. With encrypted traffic, we're just going to process the metadata. Which means that you've got encrypted packet data reduced essentially to metadata, which is very akin to flow. Like it's a very similar data set to flow. But you're paying for all of the architecture, the complications, the storage, the taps and spans in order to capture the payload that then you can't actually ever get access to. So really just you're adding all this extra work, but not getting the benefit of that extra effort that you put in. So the bottom line is that, yeah, packet capture technology, super effective, gives you very deep understanding of what's actually happening. But it's point specific because you likely do not have the budget to put it everywhere in your environment or the resources to maintain that. So you're going to put it at certain areas. So you get really point specific surgical use of packets, but you don't get a wide view of that. The other thing is that packet-based network solutions, because they're limited in their totality, they also limit the visibility, which leaves you exposed to misdetections, threat actors hiding in your network, doing activities that you cannot see. There's less validation of your other security controls. It just puts you at a higher risk of breach. And then packet-based solutions also come with costs and complications that honestly can be avoided by choosing a flow-based NDR solution. A flow-based NDR solution is going to give you better visibility, more security context at a lower impact to your resources, and it's going to have better scale. You don't have to re-architect something in order to add more devices, add more network space. It's much easier to scale, more cost-effective. So to recap, we went through a series of myths. So is NetFlow useful for security? Yes, it is. Can NetFlow detect sophisticated attacks, threats? Yes, it can. Is NetFlow limited to a small number of devices? It is not. It's a wide number of devices that can export NetFlow. Does NetFlow consume a lot of bandwidth? No, it does not. It's very negligible, the amount of bandwidth that it consumes. And finally, is NetFlow as effective as full packet capture? And from an effective standpoint, the answer is yes. It can provide you with just as rich security intelligence. It can detect, investigate, and respond to threats in the same way that a packet-based solution can. So if you're considering an NDR solution, I urge you to look at Plixer's NDR because it can help you improve your security posture. It can reduce costs, consolidate your vendors because we do both security and network performance information from the same platform, same license tier. It gives you an overall asset discovery tool with endpoint analytics, and it provides quicker time to value. People can deploy our solution in hours. Depending on your environment, it can be a very quick deployment. You can start seeing results as soon as you turn it on. And Plixer is just going to give you quick data. It's going to be easier for you, and it's going to provide you more context. And with that, I'll leave you with Jim.
And again, I want to thank you all for joining us today. As you know, these are an ongoing series where we're not only informing you about our product, but also how the industry is utilizing metadata. And that's what today was all about. We've got quite a few things coming up, so stay tuned. Keep your email open for us. Make sure that you watch out for any new announcements. And as we always say, if you're looking on your network and trying to find a needle in the haystack, don't miss a thing. Utilize metadata and NetFlow and the Plixer solution to find what you need to find. Once again, thank you very much for joining, and we'll see you next time.
Yes, thanks everyone.